Hey guys, Mr. Bouchard here, and I'm here to talk to you about the how to read the periodic table today. We're going to go over how to actually read a block, and then how to figure out what subatomic particles and how many of them are there according to the periodic table. All right, so we're going to look at a couple things here. So number one, how to read the block. So number one, we have the symbol. So this is the symbol. All right, and I told you guys the symbol is either going to be a one-letter symbol, which would be an uppercase letter, or a two-letter symbol like this one for helium. It's a uppercase and a lowercase. So that's how you know you have an element, if you see that type of symbol. Okay, helium is the element name. Okay, and then 2 is the atomic number. 4 is the atomic mass. So those are the parts that you guys have to be familiar with. There's also sometimes an electron configuration, all right, which will actually be up in the top right corner. We're not going to use that for purposes of this class, but you may see that on some periodic tables that you come across. Let's go down to the bottom. Subatomic particles, you need to be familiar with once again, and you need to know their charges. Okay, so protons, as you guys know, remember the positive charge, be positive like a proton. Okay, neutrons, remember, are neutral. It's one of those words sometimes easy to misspell, all right, so just be careful of the spelling of neutron and neutral. And then electrons are negative. All right, so you can think of these are going to have positives, these are going to have negatives, and usually we'll put a 0 next to neutral because it has no charge. Okay, other things you need to know, which are also important. Number of protons is going to be equal to the atomic number. So you can extract that right off of the block on the periodic table. Okay. If the element is neutral, which most of them are, if you see no charge in the top corner, the protons are going to be equal to the electrons. All right. So that's going to be the case most of the time. All right. I'll show you one example where that doesn't happen. Atomic mass is equal to protons plus neutrons. So that's one way you can figure that out. So if they give you protons and neutrons, you'll be able to figure out your atomic mass. If they want to know the neutrons, you do atomic mass minus the protons, which that's what you're going to do most of the time, reading off the chart to figure that out. So we'll be doing that in an example very shortly. Okay, so going to the example here. All right, let me just move myself out of the way. Myself up here. All right, so cobalt, which is the atomic number 27, so you're going to write that down, atomic number 27. The atomic mass, you just extract right off, it's 59. And protons, remember, are equal to the atomic number, so that's also going to be 27. This is neutral. There's no charge up in this corner, so therefore the electrons are also going to be 27. Okay, to find the neutrons, all you're simply going to do is take the atomic mass minus the proton. So if I do 59 minus 27, you can use a calculator, it's fine. You'll end up with 32 neutrons. So most of the time, neutrons are not going to be equal to protons and electrons. There are some examples on the periodic table where you will come across where all three of them are equal. All right, so not every time that happens, though. So be aware of that. Also, sometimes you can have charged particles. All right, so here's an example where potassium, which I didn't label potassium, but potassium has a +2 charge. All right, if this happens, this is how you handle it. All right, so the atomic number, once again, is 19. Okay, so just extract that information. Atomic mass, 39. okay, this is where it differs, okay? So if we have a +2 charge on potassium, okay, it's not going to have the same number of protons in this case. Actually, I take that back. It's not going to have the same amount of electrons. All right, I apologize. What it should have instead, it's going to have 19 protons still. That's going to be equal. Neutrons still are 39 minus 19. So if you do 39 minus 19 in your calculator, you'll get 20. The one thing that will differ are the amount of electrons. Okay, if it's +2, that means that there's 2 more protons than there are electrons. So take the proton amount, which is 19, minus 2, all right, and you'll end up with the electrons being 17. All right, so that would make it positive charge because there's more protons than there are electrons. If it was a negative charge, a -2, then you would add the extra electrons, right? So in this case, it's +2, so you're going to subtract away 2 electrons to make it a positive charge. All right, so hopefully that makes sense to you guys. We're going to do more practicing with this. This commonly definitely gives people a hard time, so make sure you know the rules from the previous slide. These rules right here are key to actually getting this down. Okay, so thank you guys for tuning in, and I'll see you next time.